All right, Hythloday, I think you bring up some good points to discuss and that we can use this to find out where we agree and disagree. I just want to say that up front and an acknowledgement because, I might use my regular style here and, I might say something that you take a slight to. So I want to up front try to acknowledge because then I'm just going to get into the ideas. Okay, now first of all, you talk about this example where you wake up saying, "Oh, I have no free will," so you're faced with a choice, and how does that feed into your choice? So the point there to me is that you are faced with the decision to get up or not. If you avoid that decision, you will remain inert. Okay, let's say you're already up and you're standing there and you're faced with the decision to go into the kitchen or go into the bathroom. If you don't make that choice, you will remain inert. So as you point out, you have to live as if there was choice. Okay, so let's think, what is the effect of fundamentally thinking um, something as if, right? But not for real, but as if. Okay, let's take a mathematical metaphor, right? Let's say you have a circle, okay? So what is that? That's, Jesus. X squared plus y squared equals c squared, r squared. So it's x equals the square root of, it's y equals the square root of x squared uh, of r squared minus x squared. Okay. So whereas in another that's in Cartesian coordinates. In another coordinate system, it's just r equals, you know, the radius, right? So r equals r0. You might write that. Right now, we know because it's a mathematical example, we can transform back and forth between these and other coordinate systems, and it becomes arbitrary. It might be simpler in one system rather than another, but there's various trade-offs, and depending on the whole problem, we might choose one coordinate system or another. But what about with something like will? Okay, what about something like what you have only one coordinate system that you can understand it? That is something that gives a reality to choice as an element. All right. So you can be searching for this second coordinate system that doesn't involve choice, but see, I think there's some logical ramifications you can draw from that, right? If the system, the goal, if you have to look at it as if there is choice, then the goal is to explain choice. And I think you can logically infer through deduction, induction, whichever rules we want to find out that it is. I think there are arguments showing that if you have a system that is created deterministically, meaning by ignoring choice, you're not going to have a model in a system that ignores choice for choice, right? Now, if you can't ever find such a system and you have to live as if there is a choice, well, remember, I'm a skeptic. That means I don't think we can learn the essence of something in itself. And even granting that things are systems, you can't learn like an essence of that system, right? So it's always as if, right? This is my point epistemologically. We might be in a dream. We might be in the Matrix. We might be, as I believe, in a materialistic world. And if we're in the Matrix, there still is a materialistic world that the computers are running in, right? But in any of those cases, it's as if mass affects gravitation and attracts mass. Mass attracts mass. It is as if that is true. This is why I like the material system, because it's the one that is as if true in the most cases, right? So what you have to do, I think, to take the next step on this or whatever, that's just a way to word it, is to take choice into account. You're basically, the problem for you, since you're trying to eliminate choice as such, or you say you don't live your life this way. I mean, within this argument, you're arguing you could eliminate choice as such. Well, then that's what's before you. Eliminate choice. Because I only know of systems that take choice as the optional thing, that you have to do one or the other. To not do either is to be inert, is to be like non-living matter. Now, you use the word free will a lot. I like to use willpower. Now, what's the difference? Are we talking about something different? I mean, we're really talking about these choices. And it seems in a lot of way, like Gray Tex got on me for going ahead and using free will, but nobody's going to use this willpower thing. But what's the difference? When you are talking about questions of free will, and I'm talking about questions, like is there free will, and I say, well, is there willpower? Are those the same question or different questions? Now, my understanding of cognitive science, how people think, right? The difference is that the question is the same subject matter, right? We're pointing at the same subject matter, but there's two different systems of metaphor regarding choice and whatnot to bring in. I don't like the free metaphors because nothing's truly free. I like willpower because then energy is naturally constrained, right? So now the metaphysical dualism's out. Um, it's not a part of the equation, but neither is monism. There isn't any monastic, there's no monad of a, essential unit of this either. I've described it more as a chorus, so there is an inherent complexity to it, all right? So this is like a third category, right? Um, Now, the argument you make about determinism, I think it suffers from the fact that we don't have this kind of definition of determinism. For example, in quantum mechanics, things that are determined, they're determined by after the fact. For example, you have conservation of energy. It is even predeterminable that there's going to be the same amount of energy in a closed system. That energy isn't going to just pop in and out of existence except in a balanced way so that the conservation of energy is maintained. That part's determinable. It's the individual case that seems less predeterminable. Does that mean that the whole process isn't deterministic? No, it doesn't. It just means that you can't predetermine it. So there's this distinction, and we're talking about whether it's predetermined. So you say there is a deterministic universe. Well, I think that has to do with the fact that there are rules and patterns in nature that are taking place. It doesn't mean one of those rules can't be options. And such as your assumption that it's either random or deterministic. And if it's mixed, that counts as random. That's like saying a little bit, that's kind of like if two races, race A and race B, intertwine, and race A is mostly made of racists, they go, oh, well, that person is race B. Now there's a little bit of B that makes the whole thing, B. In reality, what we have with the mixed determinism and randomness is, first of all, not a classical kind of randomness, a weird kind of randomness that stays in balance, that follows the conservation of energy. You don't just randomly have energy added or subtracted. If it so-called pops into existence, it has to pop out as well. It stays balanced. All right. But what we really have with this mixture of the probabilism, I'd rather call it, is that the individual case can fall anywhere. It can even be a very extreme outlier. But as you have a statistical sample, it gets more and more determined looking. And this is the balance that gives us this third way, this middle way. The definition of deterministic doesn't really work that way. It's not either random or deterministic. In fact, there could be this combination. Now, it seems inconceivable, but there's forces of gravitation. You can picture that. Why? I don't know. It seems like a lot of abstraction. There's no fundamental reason that none of us can picture some sort of power that allows choice. And especially since it's not like it's free and can choose anything, even impossibilities. You have two doors, you could go through one or the other. There is no third door. You can't go through the third door because there is no third door. You are limited to actual choices, possibilities. In the quantum universe, and the whole reason we have the multidimensional interpretation of it, which I don't buy, but the reason I think it's there is because there really is more than one choice, and there's a material reality to both of those possibilities. The number of options are predetermined. Which option you take doesn't seem predetermined, neither in physics nor in our personal experiences of it. It's not like you'd be creating unicorns out of the power of your mind that could run around the forest and be real. it's more like you could go through door 1 or door 2, and there could absolutely, in a conceivability test, be conceivably a force that allows that collapse to be as we experience it. In other words, you really could have gone through door A or door B, right? So finally, I think I'll put on here a description. I gave you the watch link, but I'm going to put a bit of Roger Penrose talking about induction and describing what he thinks Gödel's incompleteness theorem means. And I think it's a really good explanation. And basically, it's just another way of talking about how you always have to start from assumptions. There is no way to have like rules of arithmetic that can prove themselves. You always need to make some assumptive rules that you take as true in order to prove something, like math is as a subdomain of that assumption true. Cheers. Here is some extra stuff. First of all, on mathematical induction. This is a great video. I'll try to remember to put the link in my description. I have these notes ready to discuss the whole video at some point.
Natural numbers, n is a natural number, 0, 1, 2, 3, and this thing is called mathematical induction. If you want to prove something which depends on a general number n, and natural number n, what you would do in mathematical induction is to establish that, I think I'll cover this over here, establish that it's true for 0, and that if it was true for n, it would be true for n plus 1, and that shows it's true for all n. So it's a way of proving things for an infinite number of things by just doing a finite number of things. You do number 1 and number 2, and you've done it for all possible n's. Wonderful. Indeed, it is wonderful.
It is, isn't it? I love Penrose. Okay.
Wonderful. Indeed, it is wonderful. Yet, now here's the famous Gödel theorem expressed in a way which I hope will make sense to people here without looking at all the complicated things Gödel does. Gödel's theorem tells us that for any set of mechanical theorem-proving rules, which I'll call R, any set of procedures, you say, okay, is this a proof? Well, you could say, it's only, you see, you could be a mathematical purist and say, this is only a proof if it follows this set of rules, you see. Okay, maybe there's R proofs, but are they all proofs? This is the Gödel thing. It says, no, they're not, because you have any set of mechanical proving rules R, you can construct a mathematical statement, G of R, that's the Gödel sentence of R, which, if we believe in the validity of R, so if you're prepared to use R, then we must also accept as true this particular sentence. Yet, this thing cannot be proved using R alone. See, people tend to get this a little bit the wrong end of the stick, I think, with Gödel. They say, oh, they're unprovable things, you see. If R are the rules that you're going to use for your mathematics, oh, you got stuck because you can't prove this. But the whole point is that if you believe that this is a proof at all, if you believe using R gives you a proof, if you believe R doesn't give you 2 equals 3, then you must believe G of R. It doesn't follow from the rules, but it follows from the same belief system that allowed you to use the rule.
See, that's what's interesting. It's a different reason for believing G of R is true. And he uses that to conclude there's something beyond this kind of logical system required. In other words, you have to assume something. Okay, so he goes on to talk about what R is. I'll just let this complete. The next note goes back a little, so I'll just play this till about 42:58.
Yeah. And there's something very subtle about that. Even some logicians don't seem to get the point. I keep getting worried by that. But anyway, they should be aware of these things, certainly. It tells you that that's not the way we operate. When we convince ourselves that something is true, it's sometimes convenient to use a set of rules like R, but that's not the reason we believe the conclusion. The reason we believe the conclusion, we believe that R works. It doesn't give you inconsistencies. Okay.
See? Okay, and then here he characterizes Gödel on arithmetic.
So here's the question here. Are computational rules, such as those provided by ordinary mathematical induction, sufficient to establish the perceived truths of arithmetic? And Gödel's theorem tells us no.
And finally, this little bit I'll leave you with.
Is that we don't work according to a set of rules. We work by understanding, and we use the rules because they help us with our understanding, that's fine. But that's not why we know the things are true. Why we know the things are true are using understanding.
He has some good examples of things computers can't really do too well. All right. Cheers.